Next problem in single proportion test. So in a sample of 1000 people in Maharashtra, 540 are rice eaters and the rest are wheat eaters. Can we assume that both rice and wheat are equally popular in the state at 1% level of significance? So given sample size n is equal to 1000, right? 1000 people, out of that 540 rice eaters, they are eating rice, and remaining, so 1000 minus 540, right, they are wheat eaters, right? Can you assume that both rice and wheat eaters are equally popular in the state at 1% level of significance, right? So we have to check both are popular, equally popular, right? Both are equal. Let x be the number of rice eaters, and out of 1000 people you are having 540 rice eaters. So x is equal to 540, n is equal to 1000. Therefore sample proportion p, which is equal to x by n, which is equal to 540 by 1000, that is equal to 0.54. So remaining, this is probability of success. Remaining, they are wheat eaters. So q is equal to 1 minus p. They are wheat eaters. So 1 minus 0.54, that is equal to 0.46. That is probability of failure. So define hypothesis H naught, both are equal, rice eater and equal are 50% each, right? So capital P is equal to 50%, that is 0.5, right? H naught is population proportion 50%. So alternate hypothesis P not equal to 0.5. Again we are using two-tail test, right? So now q is equal to 1 minus p, that is also 0.5, right? So now test statistics, z is equal to p small p minus capital B by root of pq by n. So substituting the values, 0.54 minus 0.5 by root of 0.5 into 0.5 by 1000, so you will get 2.53, right? Calculated value of z is 2.53, not 0. That is typo error, that is 2.53, right? Now tabulated value of z at 1% level, two tail, right? 1% level is, that is 99% confidence, right? So 2.58. So comparing, so the conclusion is calculated value is less than the tabulated value, therefore H naught is accepted. That means both rice and wheat eaters are equally popular in this state, right? Next problem, as random sample of 500 pineapples was taken from a large consignment and 65 were found to be bad. So there are 500 pineapples, out of that 65 were found to be bad, it is rotten, right? Show that, or damaged, whatever it is. Show that the standard error of the proportion of bad ones in the sample of this size is 0.015, right? And deduce that the percentage of bad pineapples in the consignment almost certainly lies between 8.5 and 17.5, right? So we'll see, given the random sample n is equal to 500 pineapples, right? X be the number of bad pineapples, that is the given. Out of 500 you are having 65 bad pineapples, so x is equal to 65. Therefore sample proportion p is equal to x by n, that is equal to 65 by 500, that is equal to 0.13. so good one is the alternate, probability of failure, right? So q is equal to 1 minus p, that is equal to 1 minus 0.13, that is equal to 0.87. Now standard error of the proportion, we know the formula, root of pq by n. So p is not known, so we are taking, instead of capital P we are taking small p, right? Because capital P is not given, right? That is why. So q is equal to 0.87. so capital P and small p both are same value in this case, so 0.13, and q is equal to 0.87. Otherwise you take the formula root of small pq by n, both are same, right? So standard error, which is equal to root of 0.13 into 0.87 by 500, that is equal to 0.015. so probable limit, so this is what we have to take. So standard error is 0.015, which is to be proved, right? Next they want to deduce that the limit probable limit lies between 8.5 to 17.5. So that formula is p plus or minus 3 root of pq by root n. Substituting the values 0.13 plus or minus 3 into 0.15, right? So plus value, taking the plus value, so 0.13, sorry, first you take the minus negative, right? Not negative, minus value between them, 0.13 plus 0.45 or one value, and 0.13 minus 0.045 second value. So first you take 0.13 minus 0.45, that is the lower limit, right? So that is 0.085, and 0.13 plus 0.045, that is equal to 0.175, that is the upper limit. So in the percentage, multiply by 100, right? So 8.5 in is lower and upper limit 17.5. Now 1000, no, if I can, yeah. Hence the percentage of bad pineapples in the consignment lies between 8.5 comma 17 point, right. Next problem, a die is thrown 9000 times and a throw of 3 or 4 is observed 3240 times. Show that the die cannot be regarded as an unbiased one, and find the limits between which the probability of a throw of 3 or 4 lies, right? So given a sample of n which is equal to 9000, right? This is binomial, Bernoulli, right? Because we are using dice, coins, everything is under Bernoulli or binomial. Here sample proportion p is equal to is probability of getting 3 or 4, probability of getting 3 or probability of getting 4, that is probability of getting 3 plus probability of getting 4. So probability of getting 3 is 1 by 6, probability of getting 4 is out of 6 only one possibility, that is why 1 by 6 plus 1 by 6, that is equal to 2 by 6, that is equal to 1 by 3, right? So now q is equal to 1 minus p, that is equal to 1 minus 1 by 3, that is equal to 2 by 3. Define hypothesis. Null hypothesis, the die is unbiased, right? And alternate die is biased, right? Opposite to that. Test statistics z is equal to, so here whenever you are using Bernoulli or binomial, use this test statistics. Z is equal to x minus np by root of npq. So here x be the number of 3 or 4, given that a throw of 3 or 4 observed is 3240, right? So x is equal to 3240. So z is equal to 3240 minus n 900 into p 1 by 3, root of divided by root of 9000 1 by 3 into 2 by 3. So 3240 minus 3000 by root of 2000. So you will get 5.3667. This is the calculated value of z. Now tabulated value is for all probability value, so taking that one, right? So z is plus or minus 3, that means z lies between modulus z is less than or equal to 3, right? So conclusion, the calculated value is greater than the tabulated value 3, therefore h naught is rejected. The dice is unbiased is rejected, so the dice is biased. To find the probable limit, sample proportion p is equal to x by n, so 3240 by 9000, because x is the output, you are getting 3 or 4, how many times? So x is 3240. So number of throws 9000, right? Sample. So you will get 0.36. So q is equal to 1 minus p, that is equal to 1 minus 0.36, that is equal to 0.64. So probable limit p plus or minus 3 root of pq by n. Substituting these values, so upper limit is 0.3448 and lower limit is 0.3752, right? Thanks.